Hello everyone, welcome you back to another video. In this video, we are going to discuss about asymptotic analysis. You can see here that the definition of asymptotic analysis is it is used to compare growth rate of one function with another. There will be two functions will be given. One will be like let's suppose one is fn and another is gn. We will compare these two functions and to find out which one is greater. Using some notations, we will represent that these are the notations available in asymptotic analysis. This is called big O. We will discuss. I will make separate video for each notation. Okay, so this is big O, this is small o, big omegas, little omega and theta. So these are asymptotic notations available through which we are comparing two the functions and we can find out which one is greater and which one is smaller. Let's start with big O. What is big O and how we will comparing two functions? Let's see. Before seeing this definition, let's suppose fn is one function given, gn is another function given. So big O is the worst case representation. Let's suppose one can eat 16 rotis, right? So if I'll set a limit 18 rotis, then this is its worst case. Like maximum it can eat till 18 rotis and he can eat most 18 rotis. So it is his worst case. It is the maximum limit to which it can tend, right? So big O represents that. Big O represents the worst case. Let's suppose fn is the function given. If I will write fn equals to order of g of n. G of n is greater than f of n. F of n cannot increase g of n. The value of g of n for some value n will always be greater than the value f of n for that same value, right? So let's see what is the definition of big O. So big O is the function f of n equals to order big O of g of n if there exists a positive constant c n0 such that f of n is less than equal to c into g of n. All n belongs to n0. You can see here the diagram. And so you see here f of n, this is the f of n, the green graph is f of n and the right one is g of n. So you can see here till this point, till n naught, f of n and g of n have no relation. Like here f of n is smaller than g of n, here f of n is greater than g of n, but after n naught you can see that there is a constant relation between f of n and g of n. Like after n naught, c into g of n will be always greater than f of n. If this condition happens after some value, if c into gn is greater than equals to f of n, then I will write it as f of n equals to big O of g of n. Means g of n is greater. Which one is inside the big O symbol, that one will be greater. So what is c? You can see here what is c. C is a constant. Let's suppose one example. F of n is n square. G of n equal to n square also. If n square equals to n square, for any value of n square will be equals to n square. But if I will take c equals to 2, let's suppose, then 2n square will be greater than n square. So I can write it as n square equals to big O of n square, because with some constant value multiplying with it, I am getting the g of n value is greater than f of n. So this is the constant. Definition you need to understand clearly. The definition is the very important thing in this preparation. So take care of these definitions. That will give you more conceptual clarity so that you can solve the questions easily. Let's try some questions on this big O. Here I have given some of the functions. This is the fn function and this is the gn functions, right? You can see that these are the functions I have given and you need to find out f of n is greater or g of n is greater. If f of n is greater than equals to g of n, then what we can write it as g of n equals to big O of f of n, because this one is greater. Which one is greater? That will be inside the big O symbol. If g of n is greater than f of n, then what will be the situation? F of n equals to big O of g of n. Here g of n is greater. In all these questions, we need to find it out which one is the greater function so that we can represent one in terms of other. Like we can represent one function with the big O of another function. Basically we are comparing two functions. So let's solve these questions. Which function is greater and which function is smaller? Here you can see that n square is one function and n cube is another function. N square and n cube, let's suppose you are comparing. For n equals to 0, this one will be 0, this one will be 0. For n equals to 1, this one will be 1, this one will be 1. For n equals to 2, this one will be 4, this one will be 8. From now onwards, you can see the pattern. After 1, you can see that all the values of n square will be less than all the values of n cube. Okay, so this is the thing we are getting. After 1, in 1 both are 1, right? N square is 1, n cube is also 1. But after 1, what is happening? N cube is going upward and n square is lesser than that for any value of n after 1. So this is what? This is the n naught value, right? In the previous graph we have seen that after n naught, if some function is greater than another function, then we can represent it as the smaller function equals to big O of bigger function. So here we can get that n cube is bigger than n square. I will write it as of n equals to order of g of n, because n cube is greater than n square. Let's dive into another question. So this is n square plus n and this is n square. In the previous classes I taught you like which one is the prominent term. Okay, so here this can be written as order of n square. This is not big O, this is order of n square, because this is the prominent term, and I am adding some n value to it. That will be not like having some effect. So this is order of n square only. These two are having same prominent term, order of n square and order of n square. I can write it as order of n square plus n equals to n square, and big O of n square equals to n square plus n. Both are having the same prominent term, so these are having the same weightage. So with some constant c we can manipulate such that these two will be satisfied. Here in the second case what we are getting, f of n equals to order of g of n and g of n equals to order of f of n. Let's go into the third question. You can see here that these are the two functions here given. F of n is n cube and g of n is n. Just by seeing it you can say that n cube will be greater than n. This is f of n and this is g of n. So I will write it as which one is bigger. F of n is bigger, so I will write it inside the big O notation. Let's come to fourth question. This is just 5 and this is 2n square plus 5. This is always be greater than 5, because this will be the constant term for any value of n. This will be always be 5, but this value will be changing, so this one will be greater than 5. So here f of n, big O of f of n equals to g of n, because this one is greater. Fifth question is n square and n cube. I took these questions because to give you some clarity. After that you can solve PYQs and other workbook questions. That will be some quality questions. You can use these simple concepts there and can get the answers done. Let's see the fifth question. This is n square and n cube. This one will be greater. I can write it as f of n equals to order of g of n, because g of n is greater. So I'll put inside the big O notation. Here 100 log n and log n by 100. So these are the same terms, right? This is having log n, this is also having log n. Just it is divided by 100, this is multiplied by 100. Some constant dividing or some constant multiplying will not have some effect, because there will be some c will be there according to the definition. So I can multiply something to it, like I can multiply 20,000 to it, so that this will get cancelled and 2000 log n will be there. So that will be greater than 100 log n. That is in my hand. What is the value of c I will be taking? But the main thing is you have to notice here that the prominent term, log n is the prominent term here. This one is also log n is the prominent term. These will be having equal asymptotical value. They are not equal. If you are putting log n value here something and n value here something, then you will be getting different values, but they are asymptotically equal. This can be written as f of n equals to big O of g of n and g of n equals to big O of f of n. If both are equal, then both sides it will be satisfying. Let's see here. Seventh question. N power x and n power y. X is less than y. If x is less than y, then this one will be obviously greater than n power x. So this one will be greater. This term g of n will be inside the big O notation. I can write it as f of n equals to big O of g of n. See here, n power a and a power n. For solving such type of questions, you need to have some idea about logarithm formulas and how we can compare two functions using logarithm. You need to have some idea. So there are some formulas in logarithm. You can just watch it out. Let's try these questions. N power a is here, a power n is here. So if I will try logarithm both sides, then it will not have any effect on the actual functions, right? Both will be equal. Then there is a formula or a properties of logarithm. If something is in the exponent part, right? Here a is in the exponent part, here n is at the exponent part. So if something is in the exponent part, we can write it as a log n, and here I can write it as n log a. Okay, so you can see here a is the constant term, log n is the variable, because with the changing the value of n, this term will increasing. A will not increase or decrease. This will be the constant term. Log n will increase or decrease. Here log a is constant, because a is constant. So if anything will be the base, then this will be the constant term. This one is the variable. N is the variable. Here the prominent term is n. Here the prominent term is log n. Which one is greater? N is obviously greater. So here the answer will be f of n is smaller than the g of n. So I can write it as f of n equals to big O of g of n. This one will be greater. Here it is the 10th question. This is the function 2 power n and 2 power n by 2. You can by seeing it you can clearly say that n by 2 will be smaller. This is the exponent part. This will be smaller than n, so this will be the greater term. And I suppose you can write it how to represent. You must have some idea as of now. So this is n power root n and this is n power log n. How to solve it? Let's take logarithm both side. I'll be getting root n log n. Here I'll be getting log n log n. So root n and log n, which one will be greater? This is the log n term, right? This is the log n, this is the log n. I can cancel it out. So which one is remaining? Root n and log n. Which one will be greater? If you have no idea how to calculate, just use the logarithm formula. So n root n can be written as n power half. This can be written as log n. So I am applying logarithm both sides. Then I will be getting half log n here and I will be getting log n here. So obviously log n will be greater than log n, right? Because take one example, 2 power 10. If I will be taking n equals to 2 power 10 and the base is 2 here, I am getting here log 2 power 10. So here I will be getting 10 by 2 5, but here I will be getting log 10. Log 10 will be always less than 5. Okay, so this one will be greater than n power log n. This is 2 power n and this is n power root n. So using the same technique you can solve that. After applying logarithm both sides, I will be getting n log 2. Here I will be getting root power log n, right? So here you can see that this is this part. This is the constant term. Here I am getting n and here I am getting root n log n. Which one will be greater? You can just apply your aptitude. The root n is here, n is here. So I can just write it as root n into root n. In both sides root n is there, so I can cancel one root n out. I'm getting just root n and log n. In the previous case only we have seen this comparison. Root n and log n, root n will be greater because after applying log both sides, I will be getting half log n here and I will be getting log n here. So this will be always greater. After analyzing this, we can say that 2 power n will be greater than n power root n. Let's come to here. This is 2 power n, this is 2 power n by 2. Obviously 2 power n will be greater than 2 power n by 2. So I can write it as, if this is gn, 2 power n by 2 is gn, then I can write it as gn is less than f of n. So I will write it as g of n equals to big O of f of n. Right? Coming back to here, this question, n power log n and 2 power n. What we need to do? We need to just apply the logarithm formula. So after applying logarithm, I will be getting log n log n. Here I will be getting log n root n log 2. So this one is a constant term. I am having log n whole square and here I am having root n. So let's compare which one is greater among them. That side will be greater afterwards. So after applying logarithm once again, I am getting 2 log n. I am getting this one. So here root n is there. So I am getting half log n. Okay. So half log n will be greater than 2 log n. So this side will be greater. So this is the last question. 2 power log n and n root n. Here I will be getting log n log 2 after applying logarithm. Here I will be getting root n log n. Log n get cancelled. Log 2 is the constant term and root n is something that will be like increasing with increasing the value of n. Because log n and log n will not be increasing with increasing the value of n. So this side will be greater. So here in the last thing I can write it as f of n equals to order of g of n. That's all for today. So hope you like the video. If you like the video, please like, share and subscribe. I am not regular these days because I am having some exams. IISc has the exams and other family tensions are there. So but from now onwards I will try to be regular and upload as many as videos for you guys. So thank you and all the best.